All right, for the remainder here of our practice, number 4, we were looking at the word problem. They were looking for length and width for the dimensions of the pool. So again, just simply looking at this as a factoring problem, they both have an m, so I'm going to take that out, which means I'm left with m minus 6. And there it is. The length could be m, the width could be m minus 6, or vice versa. But there's your two dimensions. Now, number 5, there is a slight mistype in the problem here. I want you to switch the 12px and the negative 3xg, switch their positions to make this one a little bit easier to look at. But anyway, because there are 4 terms, I want to check for a GCF here first, but there's not going to be anything that they all 4 have in common. So I'm going to go to that grouping technique that we learned at the top of the page. So first 2 terms both share a g, so we'd be left with g minus 3x. For the second 2 terms, they both have a common factor of 4 and a p. Now, I'm going to use this first set of parentheses to my advantage here, because I want to make sure that what's left over after I take out this 4p is the same thing, g minus 3x. So if I divide 4pg, negative 4pg, by 4p, the problem is that I'm going to have the g, but it's going to be negative. So I'm going to take out a negative 4p, so then I get positive g when I divide. Same thing for the next 2 terms. When I divide positive 12px by negative 4p, that's what's going to give me a negative 3x. So now those 2 sets of parentheses match, and I can write out my final answer as g minus 3x and g minus 4p. So that was the grouping technique. And up here, this was just GCF. All right, number 6. So again, always pays to check for GCF first. Numerically, there's no number that goes into 16 and 81 other than 1, and they do not both have the same variables. So I'm going to go to the dots technique. And when I make my little factor trees, I'll find out 4y squared and 9w squared. Now, the first set of parentheses is positive. We have positive term plus another positive. So that term is done. We can't do anything further with that. But the second term, this is again that double dots technique. So here we're going to have to make 2 more factor trees and factor with dots 1 more time. So I'm going to put times 2 up here because we use dots twice. So 2y plus 3w and 2y minus 3w for our final answer, all factored. And again, don't forget about this front runner here. That is part of our final answer. Now for our last 2, we're looking at number 7. Again, there's 4 terms here, so I'd be scanning to see if there's anything in common with all 4 of them. Lots of commonalities, but nothing of all 4. So I'm going to go to my grouping technique. So for the first term, first 2 terms rather, x would be our GCF. For the second 2, they both have a y in common, so we'll take that out. And look at there, a squared minus b squared is our common factor. And x plus y is our other one. Now, this first term, or first factor rather, has the difference of 2 squares, so I need to factor that using dots, a plus b, a minus b, and again, I don't want to forget about that other term that we just factored out of x minus y, or x plus y rather. So this is grouping, and then we actually get to use dots. Last example, we're looking at the volume. So just like the pool one where they were looking for dimensions, same deal here. They're really just telling you to factor in disguise. So I want you to go ahead and pause and think about what you would use to factor this thing, and then come back to the video and check your answer.